Okay, let's go through our test on chapter 2. So I asked you to find the derivative of this, to differentiate this. And so we have parentheses from here to here, so that's times this. So we're going to have to use the product rule. So we're going to take the derivative of this stuff times the sine inverse of x plus the derivative of the sine inverse of x times that first stuff. Okay, so the derivative of this first part is going to be 15x squared plus the derivative of ln x is 1 over x. The derivative of sine inverse of x is 1 over the square root of 1 minus x squared. And that's the 6 points. Now let's go to this one. Now it says determine the slope of the tangent line. You don't have to find the tangent line. The slope of the tangent line is the same as the slope of the function, which is f prime. We've got to do it at this place, so we've got to find f prime of x. And it looks like we have 5x inside the tangent, inside the cube. So we got chain rule twice. Starting in the inside, the derivative of 5x is 5. The derivative of tangent is secant squared of whatever the tangent was of. And the derivative of something to the third is 3 times the something squared. And what was in there was the tangent of 5x. So that's the derivative. Now we have to evaluate that at pi over 6. So that's, we got a 5 and a 3, that's 15. And 5 times pi over 6 is 5 pi over 6 on the unit circle. That would be at that 150 degrees, pi over 6, where the cosine is negative square root of 3 over 2, and the sine is 1/2. Secant is 1 over the cosine, so it would be 2 over the square root of 3 and negative, but the square is going to take care of the negative, so it's going to be 2 over the square root of 3 squared, so it's 4/3. So I've taken care of the 5, secant squared, this. I need to know the tangent. The tangent's opposite over adjacent, so that's 1 over the square root of 3 and negative, but it's squared, so 1 over square root of 3 squared is 1 over 3. 1 squared is 1, and 3 square root of 3 squared is 3. So we get, 3 would go into 15 5 times, so we get 20 over 3. Or 6 2/3. Number 3. So we can't solve for y in this, so we're going to find the derivative of this implicitly. So we have a product here. Now we can think of this as 5x times y, or we can think of it as x times 5y, but it's not 5x times 5y. Since it's in that order, I'm just going to use this one and do the product rule. So the derivative of 5x is 5 times the second one, plus the derivative of the second one is dy dx times the first one, and that's the derivative of this. The derivative of minus 2 is 0, so we have nothing, equals, and the derivative of e to the y. Now, if it was e to the x, the derivative would be e to the x. It's same of itself. But this is chain rule because the variable is not x, it's y. So the derivative of y is dy dx times e to the y. To solve for dy dx, well, it's in this term and it's in this term, so I'm going to subtract this from both sides and get 5y equals dy dx times e to the y, and subtracting this, minus 5x. That's also times dy dx. So I just subtracted this over and then factored out the dy dx. So now, to get rid of this quantity that's times this, I have to divide by it. So I get that the derivative is 5y over e to the y minus 5x. So there was 6 points. Now we just got to figure out how to plug in the point that we're finding the slope of, at that point. So we got to put the y equals 3 into the original equation. So we're going to have 5x times 3 minus 2 equals e to the third. To solve for x, I would add 2. 5x times 3 is 15x equals e to the third plus 2. And then divide by 15. And I get x equals e to the third plus 2 over 15. So the point that we're finding the tangent line at is e to the third plus 2 over 15, comma, 3. So we plug this value in for the x, 3 in for the y's, and we get what the slope is. So we get 5 times 3, 15, over e to the third minus 5 times this. This 5 would reduce this to a 3. So I have e to the third minus e to the third, a third of it, divided by 3. So that's 2 thirds e to the third minus, and this would be 2 over 3 minus 2 thirds, and I have 15 over that. And if I wanted to, I could multiply by 3 in the numerator and the denominator, and I would get 45 over 2e to the third minus 2. That's the exact slope. But let's see what it is in decimal. 45 divided by parenthesis 2e to the third minus 2. And that comes out to be approximately 1.1789. Now, I would have accepted this answer. I would have accepted this answer back here before doing any simplifying. But you did need to find the point, and you did need to find the derivative, and then you need to put the point in there. Now, you could have used the decimal value of that, which was 1.4 something. I don't know. Okay? Next one. All we have to do is find the derivative. But this is a quotient. So we got the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator over the denominator squared. Okay, so the derivative of the numerator, that's 4x to the 1/3. So the 4 is inside. So this is chain rule. Derivative of the inside is 4 times 1/3 4x to 1/3 minus 1 is negative 2/3. And the derivative of arctangent of something, well, that's chain rule again. The derivative of the inside is 2x times the derivative of arctangent is 1 over x squared plus 1, or 1 plus x squared, but the x is just what's inside, so it's going to be x squared squared. 1 over x to the 4th plus 1. That would have gotten you full credit, 8 points. 5. Determine the slope of the tangent line if it exists at minus 2. Well, ln of negative numbers does not exist. So I scored that as a couple of points. Then I said determine the slope of the line at 5. Well, this function does exist at 5. So we have to go through this here. So I see a product. So f prime of x is going to be a product for these two, derivative of the first times the second, plus the derivative of the second times the first, plus this is a sum, so now we got the derivative of this, and that's chain rule or something inside the ln. So a derivative of the inside is 2 times the derivative of natural log of anything is 1 over the anything. So the derivative of x squared is 2x. The derivative of the 2 to the x is 2 to the x ln 2. All those derivative formulas should be on your note card. So that's the derivative. Now you can do some simplifying here. You could do some simplifying here. 2 times 2 to the x, that's 2 to the 1. You could make it 2 to the x plus 1 times x. But I didn't expect you to. I expected you just put the 5 in. 2 times 5 is 10 times 2 to the 5th, which is 32, plus, excuse me, 32 ln 2 times 25 plus 1 over 5. That's the exact answer. And if you wanted the decimal approximation, let's see what we get here. Oh, I know that. 10 times 32 is 320 plus 25 times 32 times ln2 plus 0.2 or 1/5. And we get 874.72 rounded as the slope of the tangent line, slope of the function. Next one. Well, any kind of position or motion where we know the distance formula, this is the height, distance up. The velocity is, at some time, is h prime of t. And the derivative of this, 2 times negative 16 is negative 32 t to the 1, plus the derivative of 100t is 100. There's the velocity equation. Acceleration is the derivative of the velocity or the second derivative of the position. So that's going to be negative 32. And that would be, in this case, feet per second, acceleration's units. And if we're supposed to find the velocity at 2 seconds, we plug 2 in here, we get negative 64 plus 100, which is 36, and the velocity would be in feet per second. And finally, number 7, the one that people got all tangled up on. We have g of x times f of x. So we got a function of some stuff inside. So we got to do the chain rule, but the stuff inside is a product. So we got to do the product rule for the inside and then the derivative of the bigger picture. So the derivative of the inside would be the derivative of the first times the second plus the derivative of the second times the first, and the derivative of the first is 1. So there's the derivative of the inside, a product rule. And then it's times the bigger picture, g of something. Its derivative is going to be g prime of the same something. Now we just have to use the table to figure out values for all of these pieces. What's f of 0.9? 0.9, f is 1. So we got 1 times 1, or 1, plus, what's f prime at 0.9? 0.9, f prime would be 0.91 minus 1.11 over 1.0 minus 0.8. There's f prime using the central difference at 0.9 times x, which was 0.9. So there's the derivative of the inside. Now we got to find the slope at, let's see, we got to figure out where this is at. X is 0.9 times f of 0.9, which is 1. So that's 0.9. So we got to find the slope of g at 0.9. At 0.9, g slope would be 0.84 minus 0.90 over 1.0 minus 0.8. So that's G prime at 0.9, which is what this value is. Now it's just a matter of figuring this quantity out. So 0.91 minus this would be 0.2 negative, and this is 0.2. So 0.2 divided by 0.2 is 1 with a negative, so that's negative 1 times 0.9. So we have 1 minus 0.9, which is 0.1. So this whole thing comes out to be 0.1 times this. 0.84 minus 0.9 is minus 0.06 divided by 0.2. So that, if I move the decimal one place, that comes out to be minus 0.3 times 0.1 is minus 0.03.